Alright, let's haul off and do this one. This is 1030. Hang on. It wasn't assigned, but it was very similar, and I like a couple things about it. So what you need to do, he doesn't identify which section is which. So what you have to do is you have to decide that you're going to make the section like this, or you're going to make the section like this and consider this 1, 2, 3 sections, or you could do this and consider this 1, this 2, and this 3. I'll go ahead and do this one. We'll consider, okay, so what we'll do is we'll take, whoops. What we'll do is we'll take, this is section 1, this is section 2, and this is section 3. But what I'm going to do is I'm going to list them out differently, and I'll list them as section 1, 2, 3, and you can think of this as like a spreadsheet. So make a funny little table here. He says I want to know X bar. Okay, so he really wants to know this distance. So he has put a coordinate system on here for me. So what I'll do the area in this column, and this will be the sum. The sums are over here, and then I'll do X bar in this column, and then last but not least, I will do X bar area here. So for section 1, we need to know A. Well, it's 40 by, well, this is total 160. So I got 40 by 160. Section 2, it's 40 and 40, or 80 by, and it's 40 here. And section 3 is like section 1. X bar, okay, the X bar is the distance. Okay, let's look at what X bar is for 1. For 1, X bar is that distance to that point. Since that's 160, that'll be 80. Oh, well, by the way, it's the same down there for section 3. Section 2, however, it's a lot less. It's half of that, or 20. Now, what I really need to do is I should have made this a little bit bigger. But what I'm going to do now is do the calculate. Here, I'll show you what I mean. I need to figure out this number times that number goes in that slot. So let's go ahead and do that. Take a break. Use MATLAB here. Wow, these are big, huge numbers. Okay, this will be the same number. And let me figure out the one in the middle. Thank goodness it's not as big. Now I just need to sum everything into these columns right down here and these areas at the bottom, because that's what I'm going to be using, In other words, X bar is equal to the sum of the X bar A's over the sum of all the areas. So let's just, well, if I'm looking at this, I should not have put one right here. This one we're not doing. Sorry about that. Okay, drop down in here. Whoop, wrong pen. I get 16,000. Drop down in here and you get, and now we need to know what goes in here. That becomes 108,800. Pretty big number. So all I need to do, pull this number right down here, 1088 over this number here, becomes simple 68. And in this case, all the units are millimeters. So I found this. Now I got to go off and find the next section, which is actually the moment of inertia here, about the y-axis. So if you notice, the y-axis comes up here. You've seen this where sometimes they'll do it like this, but it's essentially along that axis. This takes a little thought, a little bit of difference, so let's start working on this. We'll use the table method for it. It works very well. Now, let's think about this for a minute, because what we have to do is we have to determine the IY of each of these, the 1, the 2, and the 3. Then we have to determine how far we're moving this, the distance in the x. And then we have to determine the area of each one of these. So let's create a table that looks like this. And you know what I'll do, now that we've seen this table, I'm going to shrink this one or move it under here. And that may be the best way to approach this so I can still operate close to this. And I'll even lasso all of this. Just sort of move it down the page. And I'll do the second moments right up here so I can be close to the picture. But I will need this 68 millimeter reference, so I will use it. And I think what I'm going to do, since I have plenty of space here, I'm going to copy and move things around a little bit. So I'm going to pause the video and do that. Okay, so now move things around a little bit this way, and I drew in on this a little closer. This way I can use some of this information. First things first, from our value here, this x bar was 68 millimeters. So I'm going to start making my table again. My section, which actually, let's just move it over a little bit to the left. Well, now I'll have to go straight down. So I need to just put it right there. I'll have section 1, 2, and 3 here. Next thing I'm going to put is the area of that section. Then I'll put the distance I have to move for that section. I will put the moment, this area moment, about the centroid of that section, and we'll describe each one of these. And then, believe it or not, I'll take the area times the dx there, but I will need to square that. Now the last one I will have to, I feel as though I should write the equation, and that is the IY will be the IY bar plus the A dx squared. So in essence what you're doing is you're getting this one from here, this one from there. Alright, so let's head off and take a look at this. Well, some of this was already filled out, but I'm going to keep doing it. This is your area here of section 1 is your 40 by your 160. Now, that was before, but I could write the number in here. It's the same value that's right here. So part of this table is the same. There is no X bar across here. Section 2, 40 by 80, 40 by 160. And again, you know, section 1 is that long and that wide. Section 2 and section 3 looks like that. So next we need to find the dx. Now this you have to pay real close attention to. It is the distance that you are going to move to line yourself up with this y-axis. Well, this location is 80, and 80 minus the 68 gets you 12. Section 2, you're going to move to right here. Well, this is 20 and this is 68, so in other words, 68 to this line. Let me do it like this: 68, and this is 20, so this becomes 48. Go ahead and take this back off there. This time, same thing here. I'm moving here. I'm moving this distance back here. You notice all of these points move from the centroid back to the axis in which you're worried about or determining your second area moment, which is 12. Now we need to find that moment. The old trusty dusty hang on a second. Or I can copy it from here. I'll just copy it from the other page and make it smaller. Alright, here it is. Got copied. I like this picture better than my own handwriting. Here it is. So the question is what are you looking at now? This is something you have to be very, very, very careful about. You're trying to find it about the y here. Well, you need to be careful. You've got a mimicked action here, so we're actually looking for IY. Hang on. 1/12, and I think I'll write them up here. I'm not going to put the numbers. I'll put the equation. Height times base to the third. Now let's look at section 1. For section 1, and I'm going to erase this and put it back up here. So height is 40. Base is the distance from here all the way to there, 160 to the third. Okay, so I'm going to put that right up here. Not a lot of room. Now, as it turns out, section 3 and section 1 are the same, so I can do the same thing. I think I'm going to write it like this. Then I'm going to turn around and do the base and height for section 2. Height and base are different. 1/12. The height, well, from here to here, 80. The base, well, from here to here, 40. So what you have here is 80, 40 to the third over 12. Sorry for the cramped space. I should have moved some things around. But now I'm going to multiply. Okay, think about it. This is kind of like a Excel spreadsheet. This column squared times this column ends up in that column. You can go to MATLAB and figure these numbers out real quick. I think for instructive purposes, I'll just do it right here. Let you see the window. Here's the MATLAB window. Take the D. Okay, I'm looking at section 1. Square it times. Okay, across there looks to be 40. Wait a minute. Yeah. 40. Hang on. I said something incorrect a second ago. I just noticed that. You're taking this column, multiplying it times the square of that column, and you're putting it over in here. Sorry about that. This one is simply going to be copied to that location. Okay, let me get that straight. Now let me move back to my MATLAB. Okay. Times, okay, I got the 12 squared times 40 times 160. Big old number, 921,600. Okay. Guess what? It's the same down here. All right, now got to do the next one. That is 48 squared times 40 times 80. Big number, 737.28. Two zeros. Now what I do is I take this number, add it to that number, put it right there. A little bit difficult to do, but we'll do it real quick. All right. I believe that was the first column, plus 40 times 160 brought up to the third power divided by 12. Here's what I'm doing. I'm taking this number, which is this one, which is essentially coming from right here. I'm taking the 40, 160 to the third, 40, 160 to the third over 12, and then I'm going to put it right there. Hang on, here we go. Well, now I'm relegated to, oh shoot, I'm going to have to move this over so I can remember the number. 1.45 7775 e to the 7. guess what? This is the same number. Now I got to do the one in the center. I'll go ahead and bring MATLAB back over here on top of this. Run back, see if I can find that massive number right here. I'll just copy the number itself. Plus 80 times 40 to the third divided by 12. Again, what we're doing here, taking this number from right here, adding it to this number, which is right here. Put it right there. And run back, hit that. Big number, can't remember it. Going to slide it over to the other window so I can just copy it. 7.7995 e to the sixth. Now what do? Here's what I do. I'm not interested in any of this except for I'll just have big total equal to in big giant box because it's a big giant number is, let me add all this up, and I've got these over in the other window. I can bring them back. Here, I'll bring them back. Okay, there's the 145. There's this number plus itself once plus this big giant number. And isn't that interesting? It went from E notation to just straight out flat notation, but that's okay. 3, now I lost my window here. Let me move it over. 3, 6, 9, 4, 9, 5, 0, 0, or 36.9 e to the sixth. Yeah, whichever one you want to use. And that's the answer. So this is the answer right here. Hang on. This is what you're shooting for the whole time. And give you some context around this. You know, you might want to know why you even need to know that. Now, let me give you an example, okay? You already know this is positive bending. Put a moment here. Put a moment here. It looks like the beam is bending up. Now, as it turns out, what you're going to learn in mechanics of materials is this. What creates this moment is a somewhat triangular couple. Looks like that. And if you just look at a distribution like that, that creates a moment. Turns out this is something they call the internal stress. And one of the things you're going to see is it's the moment times the distance from the neutral axis, I'll call it y. Often they'll say C for the top, MC over I, where I is all these values we're finding here. M is from the moment diagram. So what you might look at is here's a beam, has some funny moment distribution. You look for the maximum moment, i.e. the maximum shear, the maximum stress, normal stress. Stick that number in here. Go in and find what this beam looks like from a guy who's standing here staring at it. Maybe he sees an I-beam. So he might do a composite section, find the I, stick it in right here, and then figure out, well, I'll find the stress at the top fiber or maybe at the bottom fiber. And this is the equation that you'll see in mechanics of materials that pops out from a derivation. That's why the moment diagram is so important, and that's why finding these I from composite sections is so important. These are the two items that are going to be emphasized in your test. I will be emphasized on Monday for that test on Chapter 10. And then guess what? On Tuesday, that makeup exam is going to focus on the moment as a function of x, the moment diagrams. Unfortunately, you got to know the shear too, so you better know how to find the shear and moment, and there'll be some more videos. We'll talk about some of those. But again, these are two important points. And there we go.